Operators are used in evaluating expressions, a key aspect in computer programming. It is important to learn about all the operators in Java. However, in this video we are only going to cover a few, as these operators tend to be used more than the others. We'll cover the addition, subtraction, multiplication, and division operators, as well as the modulus operator. We'll also cover the increment and decrement operators. If you'd like to learn more about the other operators in the Java programming language, I'll provide a link in the description with information on them. Alright, let's go ahead and create a new Java project here, and we'll call it operators. We'll create a new Java class, and we will call it operators as well. We'll check the public static void box here, click finish. And we'll begin with the simple system.out.println statement. Inside of these parentheses here, we're going to put 1 plus 1. And if we go ahead and run this project here, we're going to get the value of 2, of course. All it did was evaluated the expression inside of the parentheses. Now, if you notice, if we put an 8 at the end of this and we run it, we're going to get 9. Now notice we didn't get 16, which you might have thought if you go 1 plus 1, which equals 2, and you multiply that by 8. That would equal 16. But we didn't get that, we got 9. And the reason we got 9 is because these expressions follow the basic order of operations. If you remember that back in grade school, that's going to be the PEMDAS, or the Please Excuse My Dear Aunt Sally. Of course, it's an acronym to help you remember the order of operations. Of course, the P stands for parentheses, E for exponent, M for multiplication, D for division, A for addition, and S for subtraction. And that is the order of precedence for these operators. In math as well, in the Java programming language. Same way in math as well, if you have parentheses within these parentheses, whatever is in those parentheses will be evaluated before anything outside of the parentheses. So if we experiment here a little bit, we're going to go ahead and put 9 times 3 minus 1 plus 1 times 8 divided by 2. And you see we get an answer of 30. And we get 30 because, of course, first it took the 9 times 3, which is 27. And then it took the 1 times 8, which is 8, divided that by 2, which is 4. So we have 27 minus 1 plus 4, which would give us 30. As you see, our answer is here down in the console window. Now you can put parentheses inside of these parentheses. Just make sure that if you put an opening parentheses, you also put a closing parentheses to go with that opening parentheses. If you have any open brackets that don't have a closing bracket, or brace, or parentheses, or quotation marks, anything like that, if it doesn't get a paired one to close it off, you're going to have errors when you run your program. So just make sure that when you put this parentheses inside of the parentheses here, you have a closing parenthesis for every opening parenthesis that you add. So going back to the print line statement here, whatever is inside of the parentheses will get evaluated first, so the 1 plus 1 will get evaluated first. So we'll have a 2 thrown in this equation, and it will follow the normal order of operations with that 2 in there, which would give us a value of 19. Now let's look at what's called the modulus operator. We use the percentage symbol, which is right above the 5, shift 5 on the keyboard, to represent the modulus symbol here. And if we put 9 modulus 4 and we run this program, let's see what we get. We get 1 down here. Now let's try another one in here. If we put 19 modulus 4, what we get is 3. Now modulus is pretty much a remainder. You do 19 divided by 4, what you're going to get is 4 with the remainder 3. 4 goes into 19 4 times. 4 times 4 is 16. And 19 minus 16 is going to be 3. 3 is the remainder, and that's what modulus gave us. Now let's look at the increment and decrement operators. To do that, we'll go ahead and create a variable of integer type. We'll call it number, we'll initialize it to a value of 1. Now if we system.out.println this variable here, of course we're going to get 1. Let me show you what happens if we add a plus plus at the end of the variable here in the print line statement. We still get 1. Now what if we add the plus plus before the variable here and we run this? Notice we get 2 down here, and that's what an increment operator is. What it did is it took the variable number and it added 1 onto it. But why didn't it do it when we added the plus plus to the end of the variable name? Let's see something here. If we had another print line statement, if we put the plus plus back to the end of this print line statement here, and we'll add another print line statement after this, and we'll put the variable number to print in this print line statement here. If you see we run this, we get 1 and then we get 2. That's because if we put the plus plus, the increment operator, after the variable name, it's going to increment that variable after the variable has already been printed. So since the print line statement encountered the variable before the increment operator occurred, it printed out the value of the variable before the incrementation. And then after it printed out, it incremented the variable number. And then when we ran the second print line statement, the value stored in the variable number was then 2, and it printed that out. This works the same way if we use minus minus for the decrement operator. As you can see here, we get 1 and then 0. Of course, it has the same effect if we add the minus minus before the variable name. What we're going to get is 0, 0. It decremented the variable before it printed the variable. So notice here, if we put minus minus on the first one, and then we put plus plus on the second print line statement, we get printed out to the screen 0, 1. First we decremented the variable, printed it out, and then we incremented the variable and then printed it out. That's the increment and decrement operators in Java. Next, I want to briefly talk about typecasting. Typecasting is pretty much converting one variable type to another variable type on the fly. So as you can see, we have 2 integer variables here, one called number, one called add. Number has a value of 1, add has a value of 2. Now if we simply add these variables together and we run the program, we get 13, as you may assume. But what if we want to add these variables together and then divide them by 2, which would come out to a value of 6.5. But if we run this program here, you can see we get a value of 6. Because it's dividing integer variables, it gave us an integer output in the console here. 6.5 would be referred to as a floating point number, not an integer number. And that's why it gave us 6. If we want to see the 6.5 here, what we need to do is cast these variables to a float. And the only thing we need to do is put float in parentheses in front of the variable name, and it will go ahead and cast these integer variables into a float for us. Now notice you could take a float off of this denominator value of 2 here, and we'll still get the same answer. We could take it off the add variable as well. We'll still get 6.5 as an answer. As long as we have one of these values here casted to a float, we will get a float as an answer. Okay, now let's see this in an application. If we go back into our middle school math classes in algebra, we can remember that we learned how to plot a line if we have the x and the y coordinate and we have a slope, where m equals the slope and the slope is rise over run. So if we plot our first point that we're given at 2, 5, and instead of going 3 up, 1 to the right, as our m equals 3 would tell us to do, we'll go down 3 and 1 to the left, which is the same thing as 3 up and 1 to the right. If we go ahead and plot these points here, we'll get a point here, here, and we'll go ahead and plot one more point down here, just so we can get a line that passes through the y-axis. Now we could draw this line this way, go through plotting all these numbers, or we could use what's called slope-intercept form, which given the 2, 5 coordinate and our slope, we could plug these numbers into the slope-intercept formula here, and it will give us our y-intercept value, which will mean we could plot this line using only 2 points, and not have to graph any more points in order to draw the line. So if we run these through the slope-intercept formula, as you can see, we get -1 as b, of course b being the y-intercept. So we'll go ahead and plot these points here, put one at 2, 5, we'll put one at 0, -1, the y-intercept. Now what we could do with what we know so far is we could create a program where we could just plug in the x and the y coordinate of the given point, and we could plug in the slope, and it will tell us what the y-intercept will be without us having to do the math ourselves. So given a point of 2, 5 and a slope of 3, we'll go ahead and create 3 integer variables. We'll call them x, y, and m. And we'll go ahead and initialize them to the values that were given to us. Next, all we have to do is create one more variable, and we'll call it b. Now in order to solve for b, we have to subtract mx from both sides, which gives us y minus mx. So we'll go ahead and create the integer b, and we'll set it equal to y minus m times x. And if we print b out to the console, you'll see we'll get that same y-intercept of -1, which is the same thing we got when we worked it out by hand, which is good. So as you can see with this program here, all we have to do is plug in the given, and after that all we would have to do is plot the first point that was given to us and plot where it goes through the y-intercept. Draw a line through those 2 points, and there's your graph. Now you might say, why would you create a program when you could just plot the points yourself, work it out by hand? But obviously when you start dealing with bigger numbers, that could start to get very tedious and take a lot of time. So programs like this come in handy to solve problems like that. An example of this is if we change these numbers up to a little bit bigger numbers. We'll set the x value of 15 and the y to 22. We'll leave the slope at 3. If we just change these variable values here and we run this program, we'll go ahead and set up our graph here. And all we have to do is put the numbers on the x and y axis that were given to us. So we have 15 on the x, 22 on the y. And if we run our program, we'll get our y-intercept value of -23. So we'll put -23 down here. We'll draw our first point that was given to us of 15, 22. Point at the 0, -23 y-intercept. And we'll go ahead and construct that line. And as you can see, that saved us a lot of time. So there's a basic use case of a Java program of what we've learned so far.